Hello. In this video, we're going to continue looking at equations that already have logarithms present, but we're going to have a few more twists and turns. So if you notice here, we have log x minus 3 plus log x minus 2 equals 1/2 log 144. Now, obviously, we have to combine these two logs because we know that you have to have only one log on each side. So a quick move of turning that addition into multiplication seems reasonable. But the other side's got this weird 1/2 in front. And the rule is that the same thing, we can only have a log. There can't be a half a log. I mean, does that even make sense? Like mathematically, drop a log from one side, drop half a log from the other side? In math, things are supposed to be balanced. And so we have to have just a log on one side and just a log on another side, nothing else. Which means that the 1/2 has to hop up as an exponent to the 144. Now we can drop the logs, or again, if you want to say it technically, equate the arguments. And we have the following. But we might be better off writing this as the square root of 144, because that's what it means to be 144 to the 1/2. It's another way of writing the square root. And then the square root of 144 is just 12. Okay, so the right-hand side simplifies nicely to 12. What about the left-hand side? This is going to be x squared minus 2x minus 3x plus 6. That's going to give us x squared minus 5x minus 6 equals 0. So we're going to get x minus 6 and x plus 1 equals 0. So x equals 6, x equals -1. Remember, we got to check these both. And if you sort of visually look back here, again, going back to the very original one, if you were to plug in -1, -1 minus 3 would be the log of -4. And we can't do logs of negative numbers, so this gets rejected. But if you imagined plugging in the 6 here, 6 minus 3, log of 6 minus 3 would be 3, that's good. 6 minus 2, log of 6 minus 2, that's 4, that's good. So that number checks out and log of 6 is good to go. When we're talking about checking them down here, you don't have to check it all the way because in fact, you're not going to get whole numbers usually for these. You would need like a calculator to check the decimals. Really what you're just looking for is to make sure that you don't end up with log of a negative number or log of 0. As long as you avoid those, that's all you're really looking for in the check. All right, here's another one. So I'd encourage you to pause the video and give this a try. Okay, so let's hop that 2 up to make an x squared. That's our first step. Then we'll combine them. Remember, the subtraction becomes division. Now we've got 1 log on one side, 1 log on the other side, so we drop it. Multiply up to 9. Now here, in terms of solving it, you could factor it, but you could also like square root both sides. So you get x squared equals 18, and you can square root. Remember, when you square root an x squared, you always get plus minus, so the answer is plus minus root 18, which technically means x equals negative root 18 and x equals positive root 18. I have a feeling like one of those won't work out. When we look back here, if we were to check this one, you would have log base 4 of negative root 18, and that's a mess. You can't log negative numbers, so you reject it. If you check this one, you have log base 4 of just a root 18. That feels a lot more reasonable. This one checks out, and you can go ahead and box it. Okay, go ahead and pause the video and give this one a try. All right, so this 7 is really interesting. A lot of ways to do this. You could take the 7 and bring it up as an exponent. But if you do that, I'm a little concerned for what might happen. So if we bring that up as an exponent, we've got this 14 here. Now remember, we would need to either convert this to exponential, or we'd need to make the 14 into a logarithm. If we're talking about base 5, that means this would be log base 5 of 5 to the 14. Okay, this is looking kind of scary. If we drop the logs, we get x plus 6 to the 7 equals 5 to the 14. Now, I can't even calculate 5 to the 14 without a calculator. It's going to be some giant number. And x plus 6 to the 7, that's going to be like so many terms here, right? So that's a crazy number of terms. And then this is like 610351562 if you use a calculator. And this just seems like it's not going anywhere. So let's not do that. Let's instead try the following. Let's divide out the 7. So we have 7 log base 5 of x plus 6 equals 14. Let's divide by 7. It's going to give me log base 5 of x plus 6 equals 2. And we could rewrite the 2 as a logarithm so that we'll have a log on both sides. Log base 5 of 25 is 2. Okay, x plus 6 just equals 25. X equals 19. And if we check it back in the equation, 19 plus 6, yeah, that's got no problems. This checks out. And we're done. So you can see here on the left, this solution was going nowhere fast. And on the right, it worked out really easily. The thing here is that we need to get rid of the 7, but there's sort of like an easy way and a hard way. The easy way to get rid of the 7 is just divide it out. The hard way is to try to move it up as an exponent, and it just makes things not a good time. So know that there is some flexibility here, and you probably want to take the path of least resistance. Additionally, I tried to hint you, it's sort of like a teacher question here, right? The 14 and the 7 divide nicely. Even if this would have been a 21, it's the same idea. It divides nicely, so I'm trying to hint at you, hey, divide by the 7. It makes your question easier. All right, now this one is pretty tricky. I labeled it a challenge problem. So go ahead and pause the video and give it a try. Okay, so the first step should be good. We write this as ln x minus 1, x plus 2 equals, we got to write that 1 as a log. Now remember, ln means log base e. So log base e of something is going to be 1. I think log base e of e would be 1, right? Because what power of e do you need to get e? The power is 1. This is a little life tip. Log base 2 of 2 is 1. Log base 10 of 10 is 1. Log base 3 of 3 is 1. Log base e of e is 1. In other words, ln of e is 1. Okay, so they're both a log. We can drop the base. X minus 1, x plus 2 equals e. Let's expand this. X squared plus 2x minus x minus 2 equals e. X squared plus x minus 2 minus e equals 0. Now remember, e is a number. E is approximately 2.71. So here I have 2 minus 2.71. So it's like minus 4.71 approximately. And let's say we don't have a calculator, so we can't actually get a decimal for this. That means we got to go quadratic formula, and these are going to be my values. This is my a, invisible 1. This is my b, invisible 1. And this whole thing is my c. Quadratic formula says minus b plus or minus the square root of b squared minus 4ac all over 2a. The reason we're using the quadratic is because we have a degree 2 polynomial, and I don't want to try factoring it, so that's why I'm just jumping straight in. All right, so that's going to give me negative 1 plus or minus 1 minus 4 times minus 2 is 8. Minus 4 times minus e is plus 4e over 2. So that's going to be minus 1 plus or minus 9 plus 4e over 2. Now, unfortunately, that means there's two values. There's x equals negative 1 minus 9 plus 4e over 2. And there's x equals negative 1 plus 9 plus 4e over 2. And I have a feeling like one of them is not going to work out. This one over here is overall negative, right? We've got negative 1 minus another number. So that's overall negative. And if I was to take that number, an overall negative, and plug it into here, a negative number minus 1 is more negative, and you can't log a negative, so this one is going to fail the check. On the other side, however, if you were to take this number and you were to check it, if you plug this into the x minus 1, because the 9 plus 4e will be large enough, even though you root it, you're still going to be bigger than 1. So when you subtract off a 1, you'll be all right. Just as a decimal in case you want to see because you're having trouble believing me, minus 1 plus the square root of 9 plus 4e, all divided by 2. This number here, x is approximately 1.729. So if you take that number, plugged it in here, that plus 2 is obviously positive. Took that number and plugged it in here. That number minus 1 is still positive, so it checks out. And this is your solution. So this one's pretty challenging for a few reasons. First off, that 1 was tricky to convert into a log. Second off, that polynomial here was a little tricky to solve. You needed the quadratic. Third off, checking between the two solutions was also tricky because you didn't have a calculator. All right, let's go ahead and take some notes on this. Again, we are solving equations with logs already present. And it's very similar to what we did in the last video. The only new thing here is if you have something like 3 log x plus 2 log 7 or something equals log of some other stuff. This 2 needs to hop up, this 3 needs to hop up before you can combine them and before you can multiply everything. In the end, you just have to have log of something equals log of something else. There can't be any numbers here. That would be illegal. You have to get that 3 up to the exponent, so it's just the log before you can drop the logs. So for an example here, let's do 2 log 2 plus log 3x minus 1 equals 1. So go ahead and pause the video and give that a try. All right, so you should get log 2 squared plus log 3x minus 1 equals log 10. So you get log of 4 times 3x minus 1 equals log 10. Drop the logs. 12x minus 4 equals 10. 12x equals 14. X equals 14 over 12, which is 7 over 6. And if you check it, 7 over 6 times 3 minus 1 will definitely be positive. So we're good to go. You can try Unit 9, Worksheet 7. And then write down any things to remember. All right, hopefully you enjoyed this video. And as always, thanks for watching.